Right, morning, guys. I hope you're all well. Welcome to another session of network architecture. Um, if you remember well, I did send through an exercise that I needed you to look at and complete, and obviously have a quick discussion on as far as today's session is concerned. So please check your emails. I'm assuming that you already would have already checked and have this particular exercise at hand. If not, let me see if I can just quickly upload it on the chat here, and then we can quickly have a discussion on it, just to understand exactly what's happening as far as configuration of your IPs and setting up your network is concerned. Right, so I've incorporated the exercise on chat. Maybe give you a couple of seconds to quickly download and peruse through it, and then we'll have a quick discussion on it. So just download on chat there, but I'm going to quickly share my screen anyways. But I suggest obviously for you to have this particular exercise opened on a separate screen dependent, and then let's see if we can compare the answers or compare the research that you typically manage to get as far as this particular exercise is concerned. So what we've got is this here. All right, so we've got a bit of a scenario. I think, like I said before, the whole purpose is just to familiarize yourself with basic setup. What this will also assist you with is your task 2, as far as your POE is concerned. What is obviously important as far as this particular exercise goes is just understanding exactly what's happening with Dhcp, how to appropriately allocate and work with IPs as far as your specific setup there is concerned. So you have a specific organization here with 5 departments. Obviously, these 5 departments are distinctively 5 subnets within one institution. So if you look at the Varsity College Santon scenario as an argument, you could have the campus area network there being comprised of 5 or 6 networks or 5 or 6 subnets. So to make it a bit clearer, let's look at the computer rooms as each, or as an example of the separate subnets that are incorporated, obviously that are likened directly to the scenario or the platform that you've got at hand here. So you've got your marketing, research, finance, and sales, and lastly, admin. And like I said a couple of moments ago, each particular subnet or each particular department is its own subnet, all right? And it's expected that it should accommodate for a growth of 25% over the next few years. Remember, just understanding that the 25% growth is what you need to look at is what's imperative here, because ultimately the time doesn't really matter if you're looking at it from this particular point of view within your networking infrastructure configurations there, because whether this growth is in 6 months, a year, or 5, it's one and the same thing. We want to make sure that we design something that can accommodate for that growth. And then currently, you've got 25 desktop machines per department. You've got the TCP IP protocol that's being used there. Remember, your transport control or transmission control protocol over your internet protocol, just defining the network layer over the transport layer over the network layer. And remember, with the transport or the TCP platform there, you're looking at guaranteed delivery, which is what we've discussed before, where some kind of acknowledgement is sent by the receiver of distinctive message there. And then on the other hand, your IP or your network layer platform deals with logical addressing, and this logical addressing deals with some kind of pathway, deals with routing in essence. So you've got an IP that's been bought as far as this particular institution goes, and naturally you're looking at setting out a future internet connection there as far as that distinctive IP goes. So we've got a 205.1.1.0. I think we all know that that falls in the class C range as far as your IPv4 is concerned. And then you're assigned the task of splitting, obviously, the network into a less than 7 subnets. I think that's just a different way, really, of saying 6, because you're looking at less than 7. So when we run our calculations, ultimately, what you're typically configuring there is 6 distinctive subnets. And then obviously servers are placing their own subnet as far as your specific setup there is concerned. So in this particular scenario, with the 6 subnets that we're going to configure, it ultimately means that 5 of them would typically have your desktop or your machines, and then the last subnet will have strictly your server. So no desktop machines are going to be found in that particular subnet, obviously for appropriate network configuration, and at the same time for security purposes, you need to have your servers arguably separate from the rest of the entirety of the network there. And what this would also mean is that we've mentioned this before. We've talked about DHCP, and we mentioned that DHCP is short for Dynamic Host Configuration Protocol. And at the same time, that specific architecture allows automatic assignment of IP addresses within any given networked environment. So obviously, the moment you get a large number of machines or a large number of computing systems there, the appropriate conventions to use there would be your DHCP, because naturally, when you look at manual assignment, more often than not, we've mentioned this before, you've got a human error issue there. And you also have an efficiency issue associated with configuration. So you'd rather have a platform that automates that process there. So ultimately what that means is when you look at your central device or your networking devices, such as your switches and your routers there, you'll need to have these manually assigned or statically assigned. Same difference would be applicable when you look at your servers. All servers will also need to have their IP addresses statically or manually assigned. So it means that from the DHCP scope, remember a scope is an IP address range that you configure as far as the actual DHCP server there is concerned. That range would have obviously a set of IP addresses, and ultimately this is the pool that you'd use to automatically assign IPs. So you've got your scope is a range or a pool of IP addresses, and ultimately now, what this distinctively means, especially if you look at task 2 as far as your PoE there is concerned, one of the roles that you need to activate as far as your specific server there is concerned is going to be DHCP, because remember there needs to be a link between client and server, and ultimately that link also needs to avail your client obviously automatically getting an IP address from the server. So that's what you've got incorporated. And we've mentioned this before, that normally when you're looking at it from obviously security and the appropriate network configuration setup there, you need to make sure that these particular servers are not part and parcel of DHCP configurations there, because you don't want a scenario where every time you boot a network or every time you run your network, ultimately your servers need to wait to get an IP address from your DHCP configurations there. That kind of creates a bit of a cumbersome process. At the same time, it's not recommended an appropriate network configuration there. So like we said beforehand and a couple of moments back, just make sure that your networking devices as well as your servers will obviously need static assignment as far as your IP addresses there is concerned. And then lastly there, you've got all routers do not support all zeros and all ones. So like we've mentioned before, more often than not, especially if you look at the scenario that we've got here, the 205.1.1.0. That's while it's an IP address that is within your Class C range there. What it typically means, if you go back here, the zero there, that's the old zeros part we're talking about, really, because this doesn't actually relate to a specific machine. It's a network ID. Because remember, with Class C, by default, the first three portions there, so the 205.1.1 would identify the network, and then obviously the last part ultimately identifies the actual host. But now, because you've got a zero there, that means that you're not actually identifying any distinctive host. That's the reason why it's incorporated as an actual a network ID. That's a typical example of all zeros, or the 0.0.0.0, typical example as well. And in essence, all ones for that particular part would obviously be 255. And remember, 255 is, if you've converted from decimal to binary, is 8 ones. And ultimately, what that will also mean is that becomes a broadcast, the last distinctive address in that range that becomes broadcast as well. Ultimately, what that typically then means is it's an address that you can't use as far as usage there would go. So remember, we've mentioned this before, that all ones and all zeros in any given IP address range technically does not or is not used, or those particular IP addresses are not used naturally, because those zeros doesn't relate or doesn't typically mean anything. And then same difference would go with all ones, where you're looking at a broadcast platform. And then you've got obviously the servers. You've got 10 servers that incorporated there will obviously be allocated the last subnet. And like we mentioned before, this particular subnet will not have any desktop machines. All servers are dedicated. All other computers are DHCP clients. And then the servers are running 2012 release 2, and the desktop clients are running Windows 10. And obviously, you've got a registered domain name there as far as this particular organization or institution is concerned. So now we want to look at how we can tackle these distinctive tasks or questions here. Do you guys manage has anyone managed to complete anything for me here? Because remember, this is a discussion. So ultimately, I would have assumed that a couple of you, if not the entirety of the group, has some contributions in terms of these particular tasks. So you've got this in front of you. So I'm just going to quickly go back to, let me switch to the PowerPoint here so that we can use that to answer these questions, or to get a sense of what's happening there. So we got that. All right, so what have you got for me in terms of the actual tasks there? I think the first question there is calculating the subnet mask that will split the IP address into the right number of subnets. Remember, we're looking at 6 subnets there. So with your subnet mask, like we mentioned before, you've got a default mask, and then you can have a custom or a variable length subnet mask, something that you can configure to suit your network needs. So you've got default, something that you work with as is, and then naturally your custom mask, or your custom subnet mask, or your variable length subnet mask in certain instances is something that you can typically then use to set up your network, or you can use to configure your network accordingly, or to your specific needs there. So what have you got for me, anyone? How do we go about this one? Has anyone got something for me here? How do you go about this? How do you go about this? How do you go about this?
Honestly, I'm not sure, sir.
Huh?
I'm not sure.
So Anthony, oh, sorry, did you try something though?
I'll be honest, I didn't, sir.
So I'm assuming probably that everyone else in session here is probably going to come up with the same thing, eh? So
Yes,
yeah,
sir,
okay.
I told you.
Yeah, I appreciate the honesty. But anyways, that's fine. So let's see what we can do here. So am I right to assume that what Anthony has literally confessed there is applicable to everyone in the crew? Or do we have someone who's got something for us there?
What Anthony said.
Okay. All right. So let's see what we can do here. All right. So like I was just saying a couple of moments ago, we want to look at we want to panel beat and customize our default subnet mask, obviously, for this particular class, that then will enable us to configure our network accordingly. So we're going to break it down into or we're going to configure our campus area network there, or our organizational network into six subnets. So like I was saying, if you compare it to what we got on campus, that would then mean that you've got 6 distinctive networks that then obviously form one main one. So let's just use the computer rooms as a typical example of what's happening there. So you've got your 6 computer rooms, which then typically then form your 6 subnets or your 6 networks. So you've got a formula that you can use for this one. And this particular formula can equate to 2 distinctive things. Remember, when you're looking at your IP addresses, naturally, you're looking at a binary setup. And that's the reason why we mentioned that an IP v4 address is a 32-bit address, because that particular address is naturally converted into binary when you're looking at it from a computer system point of view. So each distinctive portion of an IP version 4 address is represented by 8 bits. So that's the reason why it obviously becomes a 32-bit platform. Same difference will go with IPv6. It's 128 bits ultimately, because the hexadecimal assignment that you've got, or representation, is naturally converted by default into binary by the system, and that would then equate to 128 bits as far as that particular version of the IP is concerned. So this form, so if you've got if you're dealing with binary, naturally it's base 2. Right, so it's always going to be base 2 and conversion of base 2 to base 10 and vice versa. So ultimately, the formula that we're looking at here, as far as your particular setup is concerned, because it's base 2, we're going to have 2 to the power n. So we're going to have 2 to, let me bring this down a bit so that at least we can. So you're going to have 2 to the power n minus 2. Remember, we're always going to have those 2 IP addresses that we never use. That's the reason why we're subtracting 2 there, and the 2 to the power n is the whole concept of base 2 or the binary setup. This can equate to your networks or your subnets, whichever way you want to look at it, right? And then you've got so let's put this as 1. It's the same formula really, but the second one is equating to something different as far as your setup is concerned. So you've got 2 to the power n here, minus 2 equals to the number of hosts or computer systems, you want to look at it from a different perspective, per network. All right, so that's the formula that we've got there. So the same, the typically one formula that can equate to 2 things, and obviously our n being an unknown, there would be 2 different things as well to have proper mathematical inclination there and alignment really. So you've got 2 to the power n minus 2 equal to the number of networks or subnets, and then you've got 2 to the power n minus 2 obviously equal to the number of hosts, or the maximum number of computer systems per network that you can get as far as configuration is concerned. So ultimately, what this then means is that our unknown here n, if you're looking at the first equation there, our unknown is what they call borrowed bits. Right, we'll look at how we can use that in a moment, and then our unknown in the second version of that formula is equals to so this is equals to, let's say, number of zeros in a subnet mask. All right. So that's those are the unknowns as far as your specific setup there is concerned. All right. So ultimately, if you look at the first question, as far as or the first task, as far as the exercise there is concerned, our first task has asked us calculate the subnet mask that will split the IP address into the right number of subnets. All right. So ultimately, what we've got there now is, remember, we've mentioned that our subnets are going to be 6. So ultimately, if you come back here, this would then mean is we're now using the first formula there because we're looking at subnets and networks. So it's going to be 2 to the power n minus 2 is equivalent to 6. All right. And naturally, if we make a 2 to the power n subject of the formula there, we can then solve for n. All right. So making it subject of the formula, we'll add 2 to both sides. So that 2 to the power n minus 2 plus 2 gives us 2n, or 2 to the power n rather. And then what you do on the left-hand side, naturally, as you'd know from a mathematical point of view, needs to also be undertaken on the right-hand side. So what this would then mean is that we've now got 2 to the power n is equivalent to 8, because, okay, maybe let me just write it down in its entirety. Say the 2 to the power n plus 2 is equivalent to 6 plus 2 as well, isn't it? So one and the same thing. So that particular part of the equation here would naturally give you 0. So this would then equate to, this then becomes 2 to the power n is equivalent to 8. All right. So you can obviously solve for n there without even looking at without even going into any intricacies there by default. Then that would mean our n is equivalent to 3, because 2 cubed is equivalent to 8. All right, so we've solved for n, and what did we say n is in that first formula there? We mentioned that our n is what they call these are the borrowed bits. Right? So what are we going to do with these borrowed bits? Let's see what happens in a moment. So remember, we want to look at working or configuring a custom subnet mask. So in our scenario there, the IP address that has been bought by this particular institution or company, excuse me, is 205.1.1.0. And remember, we've already said that this belongs to class C as far as your IPv4 is concerned. And given that as well, it means that the default subnet mask for class C is going to be 255.255.255.0. All right, so that's a default subnet mask that we've got for class C. This is the mask that we want to then panel beat or reconfigure in order for us to have the 6 distinctive subnets that we mentioned a couple of moments back. So without even converting it into binary there, the first position, if you look at the first position associated with this, we cannot change anything here because that's already maxed out 255. Same difference there, same difference there. That then means that the position or the part that we want to customize, or the part that we want to change really as far as that subnet mask is concerned, is the last part there that is set to 0, where we can now plug in a number that can accommodate for that can then accommodate for the 6 subnets that we mentioned. So if we look at a binary representation or conversion of that, from what we already know, as far as your specific environments they are concerned, if you look at binary representation, the first part there is your 8 ones, isn't it? So this would be then 1, 2, 3, 4, 5, 6, 7, 8. The second one, 1, 2, 3, 4, 5, 6, 7, 8. The third one, 1, 2, 3, 4, 5, 6, 7, 8. And obviously the last one would then be a string of 8 zeros, which is 1, 2, 3, 4, 5, 6, 7, and 8. That's one and the same thing. So like we said before, first part, the first string of 8 there obviously cannot, or actually the entirety of those 24 ones, or those 24 bits, the first 24 bits, there's nothing we can do because you can't convert maximum to minimum, but you can obviously convert or reconfigure minimum to maximum as far as your specific setup is concerned. So what our concentration is going to be on is the last string of zeros. And then as far as that last string of zeros is concerned, we're also looking at the most significant position of that distinctive setup that is there. Because if you look at it from a different point of view, why most significant position is important. If you look at just as a generic discussion and illustration here, let's look at the number 154. All right. If you look at 154, we already know that the most significant position there, or the most significant digit or representation is 1, because 1 is representing the hundreds, then followed by 5, which is representing the tens, then followed by 4, which is representing the units. If we add a 0, or if we reconfigure the last part, let's just assume we add a 0 here, or even add a 1, whatever number you add at the end. Let's use 0. I think maybe that makes it easier for illustrative purposes. That number becomes entirely distorted because it now becomes 1,540. So if you add configurations, or if you work with your least significant position, it completely distorts the number. On the other hand, if we were to add a 0 at the end there instead, so let's the number still remains 154. As far as representation there is concerned. So ultimately, your most significant position is what you want to work with as far as your numbering platforms there is concerned, which means that if you go back to the previous slide there, the most significant position of starting from the 8 zeros that we've got there is what we want to reconfigure. So this part, remember, it's only this part that we want to work with, because everything else is 0. What's happening with the borrowed bits? Remember, we've got 3 borrowed bits here. So what that typically then means is that starting from our most significant position, or obviously continuing with the set of ones that are incorporated in that particular mask there, it means that we've got 1, 2, and 3 that are now converted into ones. Which means that ultimately this now becomes 1, 2, 3, 4, 5, 6, 7, and 8. All right, so that's what we've done with our borrowed bits. We've now just reconfigured the subnet mask to our distinctive specification. So if we were to represent that again, what our subnet mask now looks like is going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. All right. And if you were then to convert this into decimal, all right, this becomes 255.255.255. Remember, now we want to convert this into decimal, so that becomes 128 plus 64 plus 32. What does that give you? 128 plus 64 plus 32. What's your total there?
It's 224, sir.
So 224 is what we got. So 224. So this is our subnet mask. So we've just reconfigured the subnet mask to give us the 6 subnets. All right. So that's how you get the first answer there. So our first answer, as far as that particular scenario is concerned, the subnet mask now that can allow us to convert or to split the network into the right number of subnets, which is 6, is going to be 255.255.255.224. All right, so that's your distinctive representation there. If you look at the second, so this is our part 1 there. If you look at the second one, the question says, what is the maximum number of subnets that you can have with this subnet mask? So we just answered that. It's going to be 6, isn't it? So we just mentioned that this is going to be 6 subnets. This is what we worked with initially. So number 2 there, without even any calculation, is just stemming directly from what we've talked about as far as this particular setup there is concerned. So remember, it's the 6 subnets that we're dealing with as far as your specific setup there is concerned. On the other hand, the third question now is asking, what is the maximum number of hosts now associated with this particular setup? What is the maximum number of hosts you can configure per subnet? So per the 6 subnets that we've got. So we go back to what we initially discussed right at the beginning. We're now looking at the second version of that equation. The 2 to the power n minus 2 is equals to the number of hosts or computer systems per network. All right. So instead, the n in this particular setup is going to be the number of zeros in our subnet mask. All right. So the subnet mask that we've just configured, how many zeros are incorporated there? So obviously, you're going to be looking at it from a binary point of view. So what this then means is that if you come back here, you've got 2 to the power something. All right. Your n minus 2 is equals to, obviously, like we said before, hosts per network. All right. And in this particular instance, we said that the n is represented by the number of zeros in our subnet mask. All right. So we've got 2 to the power what now? So if you go back here, how many zeros do we have in our subnet mask? How many zeros do we have in our subnet mask there?
So it's in the 5.
Yeah, it's going to be 5. It's going to be 5, exactly. So it's going to be 2, because remember, you've got, this is the part that you're looking at, all right? Because we're looking at it from a binary point of view in both instances. So it's now going to be 2 to the power 5 minus 2, which is obviously equivalent to 30, because that's 32 minus 2. 2 to the power 5 is 32, and then if you minus 2, you get 30. So the maximum number of computer systems or machines that we can plug in as far as each distinctive network or each distinctive subnet of the 6 that we've got is going to be 30. All right. So that means we've got 30 hosts. And then if you look at the fourth question there, what do we have? What does it then mention here? With the fourth, how many scopes will you configure as far as, so if you look at, let me see if I can quickly share. You already have this in on screen, but just for the purposes of uniformity there, if you look at the fourth, if you look at our fourth question here, we've got how many scopes will you configure on the DHCP server for this network? So remember, we said that a scope is a distinctive, it's a range, or it's an IP address pool, whichever way you look at it. So your specific range is obviously going to be incorporated or configured in your DHCP server, and your DHCP server now is responsible for automatically assigning the IP addresses within your network infrastructure. So if you remember what we've mentioned right at the beginning in terms of the scenario, we said that the subnet that is associated with your servers is going to be automatically excluded from your DHCP scopes. Why? Because remember, those particular servers are going to have their addresses statically or manually assigned. So it now means that of the 6 subnets that we've got, only 5 of them will need DHCP configuration. So it means that the 5 subnets are distinctively their own scopes. So we've got a range for subnet 1, we've got a range for subnet 2 all the way to subnet 5. Subnet 6 is not included because ultimately, like we said before, these are going to be manually assigned. So if you go back here, if you look at that specific paragraph there, I think what we're looking at is the fourth line there. The subnet will not have any desktop clients. All servers are dedicated, and it then also mentioned that all other computer systems are DHCP clients. So it means that what it then means is your servers are automatically excluded. And I think if you go up a bit as well, you'll find now that in this particular setup, I think that what we actually are looking at is the second sentence there. You are instructed to place all servers in on a separate subnet for security purposes and have their IP addresses statically assigned. So that means that just like I was saying a couple of moments ago, you're going to be manually assigning the IPs for the servers. So with the scopes that we've got, it means that for, like I was saying, with the six subnets, one of them is automatically excluded. So you only have 5 left. So it means that the DHCP server is going to be configured to automatically have IP addresses assigned to 5 subnets, which means that you need to configure 5 scopes. So ultimately, the answer for 4 there is going to be 5, because you've got 5 subnets that will need automatic assignment as far as your IP address configurations there is concerned. So number 4 would be 5 scopes. And how are these scopes come about, or how did we get to that conclusion? We've got 6 subnets, but of the 6 subnets, only 5 of them are going to be DHCP configured. And obviously it means that each one of the subnets will have their own range. And that particular range is known as a scope. So we've got 5 subnets ultimately. We've got 5 scopes, so 5 IP address ranges that you need to then configure. All right. And then number 5 there, will the current addressing scheme accommodate for the expected growth over the next 3 years? Motivate your answer showing calculation. So we've got the 25% growth. So we go up here, they've mentioned that, look, we're looking at a growth of about 25%. If you look at the first paragraph there, the 4th line would mention that we're looking at a 25% growth over the next 3 years. And remember, like I said before, remember the time really is not as important. I think what you're looking at there is to accommodate for that growth process within this particular network infrastructure there. So ultimately now, what you want to do, I think if you can go back to our slides here, let's see if we can have some understanding of what is necessary and relevant here. So if you look at, if you open this, so if you look at this particular setup, I think we've already mentioned that for number 4 there, we're looking at 5 scopes. All right, and then for the 5th one, as far as your setup is concerned, we now want to look at that 25% growth. So what do we have? So currently, remember, we've got 5 departments. So currently, so let's just say a current setup, we've got 5 departments, all right, which are also the 5 subnets or networks. And then we've got 25 computers per these departments or subnets, all right? So what that typically means now is that currently we've got, apologies there. We've got 125 computers. All right, so that's what we currently have, all right? So we want to look at a 25% growth process. So 25% of this 125 is going to give us what we need to add on, or what we need to accommodate for over whatever time period that they've mentioned there, as far as your configuration is concerned. So ultimately, what this then would mean is we want to get 25% of 125, right? And if you calculate that, or 0.25 multiplied by 125, I think it gives you 31.25. Someone can confirm this for me. Should be 31.25. So this is our expected growth. So the 31.25 here is our expected growth, all right? Or what we need to add on as far as your specific setup there is concerned. But remember, if you're looking at computer systems, it's we're looking at it as a whole unit, really. So we can not typically have 31 point something networks or 31 point something computer systems. We're obviously going to have to round that down to the nearest whole number there. Even if it was 31.9, you'll still come down to 31, because you're looking at it from a whole number point of view. It's an entire unit, remember. So we're going to add the 31 computers to our initial 125. So what that would then mean is that we've got the 125, which is our current, and then we've got the 31, which is our growth, all right? And obviously our total there is 156. So our network needs to accommodate for 156 computers or machines, Right. So this is what we want to accommodate for. Right. So what does our projection look like with our reconfigured setup? As far as, I think, let's call that our the current configuration that we've got, or our projection, whichever way we can look at it. So let's just say configuration, what we've configured. All right, remember, as far as our configuration is concerned, we managed to come up with 6 subnets. And if you go back here, where are we? As far as these 6 subnets is concerned, we managed to calculate that we can get a maximum of 30 hosts per the 6 subnets there, isn't it? So it means if you go back to our particular setup there, we've got 6 subnets multiplied by the 30 computers. All right, and obviously that should give us 180 computers. All right, so just by looking at it, it seems that we can accommodate. It seems like we can accommodate the 156, because that number is a little bit more than 156. But remember, we've mentioned the fact that we're not using the entirety of the 6 subnets, are we? We're only using 5, because one of the subnets, or the last subnet, is going to be dedicated to the servers only, and no desktop clients are going to be incorporated in that subnet. So ultimately, what we are actually looking at is that we've got 5 subnets. So this is the generic total there, but we actually have 5 subnets that we need to be working with, because remember, the last subnet is excluded. Why? So here, the reason being, last subnet is obviously reserved for the servers. All right, so we can't use the last subnet, regardless of us still having enough space there. So ultimately, what this then means is that if you come back here, it means that we've got our 5 subnets multiplied by the 30 machines, or 30 computers, and obviously that gives you 150. So ultimately now, with what we've projected, and or what we've configured, and what we're looking at as far as the growth is concerned, so we've got 156, all right, which is ultimately the growth we're expecting, which is obviously going to be a lot larger than the 150 that we've configured, or let's just say configuration there. All right, so ultimately the answer for that question would be no. Why? Because we are looking at getting 156, but we can only accommodate for 150. So it obviously then means here that we are 6 short. So if you look at that particular question, if you go back to that distinctive question there, what it typically then means is question number 5 there would it will be no, and obviously we've just shown it through calculation. So number 5 would be no, and we've just shown that through distinctive calculation there, as far as your setup is concerned. All right, so that means that no there, and obviously the reason we've shown calculation. So we can just say no, a scheme does not accommodate we got the right spelling there. Accommodate all right, so we sorted there as far as that particular question there is concerned. And then obviously the 6th one, as far as configurations there is concerned, with the 6th question, they've asked you here that how will you ensure that all DHCP clients get an IP address? So this is directly linked now to your task 2. In one, I think you got a question there for task 2 that's dealing with DHCP configuration there. I think it should be a 10 or 15 mark question as far as that particular assessment is concerned. So ultimately, what you need to ensure is to obviously configure the correct scopes. So configure the correct scopes. All right, and then once you've done that, ultimately you obviously need to and then ensure that clients are linked or connected to the DHCP server. So there actually has to be a link between these entities, because if there's no link, then it obviously means that your clients cannot get that service. Remember, we've mentioned before that your server is a dedicated machine within your network environment that is responsible for a specific service, or that is that provides a specific service. But remember, those services can only be gotten if the client is directly linked to your server. I think if you remember with the session that we had on network architectures, when we're defining peer-to-peer as well as client server and directory-based, inclusive of hybrid network architectures, we mentioned specifically that your client is a machine that is or client server setups. You've got distinctive roles where you've got a client that is part and parcel of the network that gets its network services from another computer system that is your server. And obviously, in order for those services to be appropriately used and accessed, there has to be a link between these devices. So ultimately, you need to make sure that you configure the right scopes or the right IP address ranges first. And then once that is done, then obviously make sure that there's a link between your clients and the actual DHCP server there as far as your configuration is concerned. So ultimately important for you to make sure that you configure appropriately, and then also ensure that you've got the right connection or link between the clients incorporated there. The 7th question, on the other hand, now is asking you to work out the first, last address of each subnet, and ultimately also distinctively look at the whole issue of the broadcast setup. So you've got working out the first address of each distinctive subnet. So as far as the 6 subnets that we've managed to get there, we want to work out the first and last address, and then look at making sure that we incorporate the subnet address as well as the broadcast address. Remember, normally broadcast addresses are the last address within any given range. And ultimately, the first address is the one that defines or indicates your subnet or indicates your network ID. And then ultimately, that particular address is normally assigned to your router or your switch, depending on configuration there. So the first address of any given range is the one that identifies the subnet, normally associated with the router. And then as far as that particular range is concerned, the last range is obviously going to be, or the last address in that range is arguably going to be broadcast, and it's not even assigned to any given computer system. So the first address of each one of those subnets is going to be incorporated with your routers. So I think if you look at what we've got here, where are we right? So the routers connecting the subnets will be allocated an IP address before any are allocated to the computers, and will be statically assigned and excluded from the DHCP scope. All right. So it means that single IP address in that subnet is not part and parcel of your scope or your assignable range. And then you obviously have to have that first address for each of the subnets being statically assigned. So instead of using switches here, we're going to be using routers for each one of the subnets to identify them as a separate network within the entirety of the configuration that that we've got there. So how we go about this, let's see if we can get some understanding in terms of what's actually, before we even change up, remember, we're going to be working from the 205.1.1.0. All right, so that's the network ID that we've got. That's the IP address that we're going to be working from as far as allocation of IPs in within the actual 6 subnet configurations associated with your network there. So if we can just go back to our presentation. All right, so if you go back here, what that means now, if you're looking at our first, so we've got 6 subnets. So our first subnet, or subnet 1, whichever way you look at it. Remember, we've got 205. So we've got this address here, 205.1.1.0. All right, so it means that we're going to be starting from 1. And then incorporating 30 IP addresses in each distinctive range. So if you look at it from a different perspective here, it means that our first address is going to be 205.1.1.1, and this particular address is going to be given your router, and obviously this typically presents the net ID. All right, and then the second address, which is 205.1.1.2, is the one that now can be given our, so this is our first computer system. So this is now part of our range, all right? And then, or part of our distinctive scope. And then ultimately, the last computer system there is going to be 205.1.1.29. So that's our last computer. And then 205.1.1.30. Remember, we've got 30 machines per subnet is going to be our broadcast. So if you look at it from a different point of view now, as far as this particular subnet is concerned, when we're configuring our scope, it means that our range or our scope will have ultimately 2 to 29 there, because remember, normally if you want to look at it from a very specific point of view, the last address is going to be your broadcast. So our actual scope, all right, as far as the first subnet is concerned, is obviously going to be this is what you're going to configure on your DHCP server now. It means that 205.1.1.2 all the way to 205.1.29. Because the first address, as you can see here, our first address is not part of the scope, as we've known as far as the actual scenario is concerned. It's not part of the scope there because that's going to be manually assigned to your router. And then the last address is also not going to be part of the scope because remember, this one is dealing with broadcast. So our actual scope is going to be from 2 all the way to 29. And then if you look at the second subnet now, so here, if we look at it from this point of view, so our second subnet, remember we've got 6 in total. That means that our first address now, what was our last one there? Our last one was 30, right? So our first address is going to be 205.1.1.31. That's going to be assigned to your router. Like we said before, that's your network ID. And then the first assignable or the first IP address that actually can be granted or given to a machine there is going to be .1.32. So that's going to be your first computer. And then 205, remember it's 30 per subnet, right? So 205.1.59 is going to be your last computer. And then obviously 205.1.1.60 is going to be broadcast. So which means that if you look at our scope for this particular, our second scope here is going to be 205.1.1.31 all the way to 205.1.1.59. And like we said before in the previous one, that one is net ID, that one is broadcast. So our scope is actually going to be 32 to, oops, my mistake here, 32 to 59. So my mistake, apologies there. This is actually supposed to be, this number here is actually supposed to be 32. All right. So I think you can, you've got enough acumen now to go through, I think you can now on your own, from that understanding, you can now work out subnets 3 to 6. All right, subnets 3 to 6. And just remember the last one is not going to be part of the Dhcp scope as far as your setup there is concerned. Everything is going to be manually incorporated there. All right. Okay, do we have any questions or contributions? You see how simple that was there? I think you had no excuses for not attempting this one, guys. So any questions or contributions or concerns as far as that is concerned? Is it making sense for everyone there? Is it making sense for you?
So how many marks would 7 questions like that be for?
Normally, I think if you look at, let's see what we got. Normally, if you look at, this is easily especially if you look at for instance, the last question there with the 6 subnets and so on, they could have that with remember you're looking at first last address, subnet address and so on. So that could be easily a 5-mark question per subnet. So number 7 there can easily be a 30-mark question. All right, so number 7 can easily be a 30-mark question. So if you look at one, quite simple, it's to do with basic calculation. So I think let's go back here. Let's see what we got. So with the first one, where's our first one? So with our first one there, you're looking at generically 5 marks. For the second one, that's a 1-mark question. For the third one, that's another 5 odd marks there. For the fourth one with the 5 scopes, that's a 1-mark question, at maximum 2 in certain instances. And then with the 5th question there, you're looking at again another 5-mark question. And like I was saying with which was the other one? So this was our growth process there, right? And then with number 6 there, that's typically a 2 or 3-mark question. And then lastly, like I was saying, it's 5 marks a piece really for each one of the subnets that you've got. So that's easily a 30-mark question as far as your specific setup there is concerned. All right, hopefully that answers your question there, Anthony. So if you look now at what you're going to be doing as far as the practical session there is concerned for task 2, like I was saying some time back, that you've got an actual question that will require you to set up and configure Dhcp there, and then incorporate the right scope that will then enable you to have your client link up accordingly and obtain an IP address from the actual server that you'd have installed. So we're going to start working on, I think we need to start working on the on installation on our virtual machines from next week onwards. At least you can get the ball rolling. You've got the first assignment now, the first task done and dusted already, which is obviously due later on today. I'm assuming that most, if not all of you, have already submitted that, and then let's start concentrating on our virtual machines, their client and server, and then I think they'll schedule some sessions on campus. I think some communication must have already gone out. So technically, what that would then mean is we'll have one session a week, really, on campus, face to face. So what that would mean, I think we can then also use those sessions to start working on our cable. Remember, if you look at some questions associated with the actual POE, you're supposed to create your straight through Cat6 or Cat5e cable there, as far as twisted pair is concerned. So I think we'll use those sessions to create these cables, just to make sure that we're all on the board there. But as far as our virtual machines they would go, I think we can start working on these sometime next week. If I'm not mistaken, I think we have a session of next week. If not, probably in the next 2 weeks. And then obviously by then, I should have some kind of feedback or marks associated with the assessment or the task that you've submitted as far as today there is concerned. So just make sure you got the software that we mentioned before. I think if you're not, if you've not gotten the actual, or if you're not part and parcel of the session that we discussed this in, you can always check the clips. I think you've got one session. I think the session that we're discussing. I think with the servers, if I'm not mistaken, there's a session there that I give the actual spec associated with the machines that you need to have. I think we talked about at least looking at a Core i5 processor, 8th gen, really, as your minimum, and then you can talk about the Ryzen or the Ryzen 5 on AMD. And then 8 gigs of RAM with about 512 storage space. SSD preferable, but traditional will still work. And then at least having 100 gigs free, because we're going to get to, I think we're going to be using about 50 gig per machine. So it's important. And then I think the most important thing really is making sure that the processor that you've got can accommodate for virtualization. So you can always check for that in your BIOS. To see if the processor that you currently have can accommodate for virtualization, because if it doesn't, then it means that we can't we can't simultaneously run the virtual machines. Remember, the whole issue of virtualization is looking at a processor that can run, or virtualization is ultimately running multiple OSs simultaneously. And what provides for that is the processor that you've got. So ultimately, take heed of that. And then, yeah, so we'll start working on that. So the softwares that you need, I've already mentioned. I'm assuming that you have already downloaded these. If not, they should be up on your FTP site. If you're still having issues finding the ISOs, because you'll need an actual ISO, not an EXE for these machines. So make sure you've got an ISO for the Windows 10 Professional and an ISO for Windows 12 Release 2. Remember, you need to go professional, because if you use the Home Edition, unfortunately, we can't look at joining domains or working with domains in our setup. So just make sure that it's actually Windows 10 Professional, and as far as the server is concerned, 2012 R2 or Release 2, and then make sure that they're ISOs as opposed to EXEs, because remember, we're working it in a virtual platform. So instead of using a generic setup file there, we need to work with an ISO platform. All right, so you can start preparing that, so that at least the next session that we've got, we can work on that. Let me just see if I can confirm when is the next time we actually do have sessions, so that we can start discussing that. This is group 2, right? So this timetable that now includes level 2. All right, so second week, so we still have online sessions next week. No, that's fine. So in that online session, I think we'll just start discussing the whole concept of setting up your virtual box, how to set up your machines and have them installed. And then in our second session, which will be on the 16th, we'll start the whole issue of making sure that we can link them up accordingly. And then I think we've got a week break from the 21st to the 25th, meaning that the 29th now will be on campus. And then we can hopefully that particular session there, we can start working on our cables. I think what I'll do is send some info beforehand that you can work with in terms of how to distinctively create your cables there. And then once we're on campus, hopefully the material will be present for us. We can start working on our cable creation there on the 29th of this month. It's normally it's what it's if you do it correctly, it really shouldn't be more than a 30-minute process, depending. And if you've done cabling before, you should find this particular session rather quick and simple. But it's still all well and good there. We'll have enough time to complete and conclude content. All right. So do we have any questions or contributions as far as today's session is concerned? Like I said before, probably before you answer that or send through your questions and so on, just I sent through an email yesterday. I think there was a bit of a confusion. I just realized and identified that I think with the third and the second, the first and the third group, there seemed to be a bit of confusion in terms of dates and submission and so on. So the task, if you look at your POE, like we've discussed before, task 1 is the same thing as assignment 1 for this particular module. I think the links are already up now. You are submitting everything on Teams, remember? And you need to then make sure that you also submit with the Safe Assign report. So if you're going to be using Visio for your network diagram, that means you're also submitting that as a separate file. You're not taking screenshots and incorporating in a Word document. Make sure that you incorporate that as a separate file, and you obviously save it accordingly to say maybe this is question 2, 2.1, and 2.2. And then obviously the rest of your Word document there would have questions 1 and questions 1 or activities 1 and 3 there. Your diagram is separate. If you're going to be using Smart Draw, I think a lot of individuals had issues with converting or saving it as a JPEG file. So ultimately, what you can do now with if you're going to be using Smart Draw, you can, and I think Smart Draw also has watermarks that incorporated there, but they don't distort your image. Everything is still legible. If you're using Smart Draw and you're having problems saving it as a JPEG, which is what you will then need to submit as a separate file as well, you can then incorporate a screenshot and then plug it into your, or you can then add it or insert it as an image on your Word document. Rather than taking a screenshot, just insert your image into the Word document. And then obviously from there, I can always, if need be, if it's not as legible as it's supposed to be, I can always download it directly off your Word document and be able to mark accordingly. So take heed of that fact if you haven't done so already. And then should you still be having issues, remember we've got a clip that we've recorded and uploaded on YouTube there that discusses the task in its entirety. So should you have issues there, have a quick look at that clip. And if things are still a bit hazy, pop me a mail and then we can always conclude accordingly. Although what it would then mean is that you've got a couple of hours now. So if you've got 1 or 2 questions or parts of the questions that are still giving you a bit of an issue there, I suggest you pop me a mail or probably even use this session to ask, so that you can then conclude conclude accordingly and before time to avoid any discrepancies there. Remember, with this semester, then there's no second submissions, there's no recommended dates and so on. Whatever date you've got on your pass is the one that is applicable for submission. If you miss that, unfortunately, you get disqualified for that assessment, and you'll then need to communicate with the Student Hub in order for you to either get it reweighted or be availed an opportunity for resubmission, which probably if you were sick or something like that. But everything has gone back to normal there in terms of the way in which we submit. Remember, at the conclusion of semester one, I think we had to more or less customize submissions for assessments because of the lockdown. But now we've gone back to the normal way of submitting content. So the dates are literally set in stone. So make sure you stick to those dates as well as the distinctive times within those dates. All right, so as far as today's session is concerned, do we have any questions or contributions there? In terms of the exercise that we just looked at, or in terms of the scenario that we just looked at, do we have any question or contribution there?
No, sir.
Okay. Okay, cool beans. And then as far as the assignment or your task one, are we all good to go on that one?
So I have a question, sir.
Yeah, what's happening?
So can a switch be a subnet mask, or is it just routers?
You can configure to identify in a network, so that's possible. Although your more appropriate device would be a router. So if you look at I'm assuming you're asking with regards to task one, right?
Yes, sir.
So what would happen with task one? Remember, we said that you've got a minimum of 20 machines there, all right? And that those 20 machines, you've got a combination of desktops, laptops, as well as your tablets, all right? And then ultimately, you can use ultimately one switch for that, because you've got 20 machines. You can use a 48-port switch that will then also connect your printers. Probably you might have two odd printers in that network setup, and then that will also connect your access points. All right, and then you also would need then a router that would enable connectivity to the net. So I think let's see if we can have a quick. If you look at this particular point of view, I'm just going to add. Let's see if we can have some kind of illustration there that can make sense for us. So what you're looking at really is so ultimately you've got an actual switch. So this is incorporated within your server room. So in your server room here, let's assume you've got your. So let's assume here. Let's have this incorporated. So in your server room, you've got your rack there, and then as far as that rack is concerned, you've got your switch, you've got your router, and you've got your server incorporated there. All right, just to give you an idea of what is actually happening here. So this particular router is the one that enables connectivity to the net. All right, and then as far as your switch there is concerned, this particular switch will then connect your 20 devices. This particular switch will also connect your printers. This particular switch will also connect your APs, because remember, your access points are the ones that are providing a wireless communication there. All right, and obviously at the same time, this switch has got connectivity to your router as well. That also has connectivity to the server there. So if you look at it from a distinctive point of view, ultimately now what you've got is the switch. You just need one distinctive switch, because this particular switch can be a 48-port switch. Or alternatively, you can then say, okay, look, I'm going to go 24-24. So you can put two switches that are 24 ports each, and then configure accordingly as far as setup there is concerned. So if you want to look at it from a diagram, from another point of view, so this is within the server room. So this is an actual rack within your server room. All right, as far as basic connectivity is concerned. So if you want to look at it now from a diagrammatic point of view, you can have a one switch there that then connects the multitude of devices. All right, so that's computer system. That particular switch also connects, let's call that your printer. And then as far as connectivity is concerned, this switch connects to your server. This particular server is connected to a router. And obviously that router is connected to your internet space there. All right, so that's our router, that's our server, and this is our switch, and these are our computer systems, and this is our printer. All right, and then as far as that there is concerned, what you can then also do is that this particular switch will also connect your APs. All right, for that wireless communication. So technically, this is what you've got. So ultimately, you can then say, okay, look, I can have two switches there to accommodate for, but ultimately, in essence, that one switch that you've got incorporated can still be applicable as far as the basic setup there is concerned. So this is what you've got as far as connectivity. Obviously, the linkage there is all bounded. So you still have a bounded connection to the AP. You've got a bounded connection to the computers. So here, if you look at it from a different perspective, these are your computers. As far as your particular setup there is concerned, and obviously we've mentioned that this is your switch. These are your printers. You can have more than one there, and obviously your access points for Wi-Fi connectivity, and ultimately that's your router there. So this is what your basic network setup would look like. But remember, you need to make sure that you incorporate the entirety of your computing platforms there, because what you can then say is, as far as your APs there go, you will then now need to incorporate maybe your tablets there, just to show that these tablets are connected, or your laptops. So this could be a tablet, this could be a tablet, this could be a laptop, depending. All right, so that's a typical example. So that's a tablet there, same difference there, and then that's your laptop that are all connected wirelessly to that access point. So you can have more than one access point. You might have two if you want to look at it from a range point of view. You can just say, okay, to accommodate for the entirety of the office, I can have two access points, and at the same time, you can have two switches. Although one is enough, you can have one 48-port switch there, or two 24-port switches, like I mentioned before, and then you can have two APs to accommodate for the range. But in essence, this is what your basic diagram should typically look like. I don't know if that makes sense for you there. Is that making sense for you there? I think it was Kiddes who asked the question.
Yes, it does make sense.
Okay,
Yes.
cool. Okay, cool. All right. So, do we have any other questions there in terms of the assessment that is due?
Sir.
Yeah.
So in this drawing, the router is the subnet mask, not the server.
No, the router is your remember the subnet mask is there by default. The router is the one that defines your network. So ultimately, in essence, like if you look at the previous or if you look at the exercise that we looked at today, your router's main purpose is just to enable connectivity to an external platform. So in essence, that same router is the one that defines your network, or you can still have that configured in your switch. So each distinctive, so as an example here, if I was going to go with a specific naming convention, I can then say my switch here can be maybe 192.168.0.1, for instance, or maybe let's put that as probably as .2. Our router can be 192.168.0.1. Our server can be 192.168.0.3. And then you can have also need to have IP addresses for all of these IP addresses for all of the other connected components. So your APs need to have an IP address. The tablet needs to have an IP address. The laptop, same difference. Your computers, same difference as far as connectivity there is concerned. Then you will need to separately mention that as far as this particular network is concerned, the subnet mask that you're using is going to be 255.255.255.0. So the subnet mask would be for the entire network. You don't have to put in a subnet mask for each individual device there. You can just mention that, okay, look, as far as the specific network is concerned, I've decided to go with this naming convention. I've decided to go with these IP addresses. The subnet mask that I'm going to be using for this network is going to be this, as far as illustrations are concerned. And if you want to go extra, remember, because you've got an internal addressing scheme there, obviously NAT needs to be incorporated. So NAT, remember we said that your network address translation's main purpose is to translate or to hide internal addressing schemes from the external network so that you can use one public IP address to connect a multitude of computer systems. You can then have an example of a public IP address, like for instance, 156.37.1.18, that will then enable connectivity to the external network. And like we said before, internal addressing schemes will only see this as their router or as their specific public IP or the IP that enables connectivity rather. And then the external network that is trying to connect to your setup will only see that. So it seems as if there's only one IP, but there's a multitude of gadgets that are sitting behind. And at the same time, if anyone was to run the IP config command from your internal space, they will only see the 192.168.0.1 as the router or as the gateway that is enabling connectivity to the external network. All right. So every connected machine, every connected device needs to have an IP address. So an AP will have an IP. Your printer will have an IP. Your computers will have an IP. Your switch will have an IP. Your laptops have an IP. Your server have an IP. Your router will also have an IP incorporated there. So just make sure that you incorporate content accordingly as far as your diagram is concerned, if you haven't done that already. All right, do we have any other questions there? Any other questions or contributions? Any questions or contributions from the floor there?
No, sir.
Okay, so I'm assuming that that's the same for everyone. So let's get cracking. Make sure you submit on time. Like I said, if you haven't already, if you have, then kudos to you. We'll have a quick look at it, and then hopefully by the end of next week, your marks should be ready as far as that particular first task is concerned. All right, so if there are no questions, contributions or concerns, stay safe as usual, keep smiling, be of positive spirits, and we'll see you in the next session. Cheers.
Thanks, sir.
Yes, sir.
Thank you, sir.
Yes, guys.
Yes, sir.
Cheers. Thank you, sir.
Cheers, guys.